Welcome back. Today we're going to be doing a little bit of Zephyr review. Zephyr is something that we use a lot at Goliath. It's a real-time operating system. It allows us to bootstrap a lot of our examples and show you how to connect your devices to IoT easier. Today I'm here with Marcin, who's one of our Zephyr experts. Thanks for joining us, Marcin. How you doing?
Thanks, Chris. I'm doing fine. How are you?
I'm great. So today we're going to be talking about overlays, which is kind of a simpler topic in Zephyr, but pretty critical, I feel like, for, we show it in some of our examples. We show, it's basically how you can customize your hardware, customize some of the things that you want to use in Zephyr. But we were talking a little bit before we recorded, there are actually two different types of overlays. What are the two different types of overlays?
So we have two types of overlays. One is for application configuration. So it allows you to configure, for example, the networking stack, which protocols you want to use from your application. So it allows you to select UDP, TCP, IPv4, IPv6. It allows you to configure how many network buffers and packets you want to allocate. It depends on how much network traffic you will make from your application. And yeah, so in general, it's something that configures your application, your software. And the other overlay is for device tree. And as the name device tree says, it is related to configuring your device. So you can configure which sensors do you have connected, which bus you want to use for communicating with your sensor, and all stuff related to hardware, like you configure where the LEDs are attached to your board, to which GPIOs, where are your buttons, etc.
Yeah, and the whole idea of an overlay kind of feels like a system of inheritance to me. It's almost like if there's something in the system that tells the board is like NRF91 or ESP32, it's like, hey, pin 25 is an output, and it's just an output on this board, and you do whatever you want with it. But then when you do an overlay file, like a device tree overlay, you're basically saying, well, actually, no, pin 25, I want it to be an output, but it's a PWM output or something like that, where you're giving it some other kind of, you're kind of hooking things together, and you're saying, this is what I'm using that base level thing for. Is that a good characterization?
There's always a device tree that specifies what are the components on your board, and when you add overlays, device tree overlays, you add some new functionalities to for example, to GPIOs that you didn't use before. So if you have a development kit, there are either there is one LED, there are no LEDs, or there are just few LEDs, but you want to use the GPIOs that are on the pin headers. And with device tree overlay, you can configure the single GPIO that you want to use in your application.
Yeah, and we'll do other examples in the future, but you start adding sensors like an I2C sensor or SPI sensor. We've talked about doing adding Wi-Fi over SPI, that sort of thing. It's like, it really can get pretty it's actually not a super complex thing when you read it, but you can do some very interesting functionality, it feels like, using these overlays. And so really it enables people to kind of bootstrap up quickly, and that's what we're excited about here. Let's take a look at one of the ones from our examples. So we have some examples for LightDB, which is the database that Goliath uses, basically allowing you to push configurations, pull configurations from a remote device like an ESP32, and we actually show how to add LEDs. And this is something that I showed in another video where I have basically an ESP32, this little janky board that I built, just lighting up LEDs on here, and so I added a device tree overlay, but you're going to actually show what this looks like here on your terminal.
Yeah, so here we are in the Goliath SDK directory. This is already configured with the West modules that are needed, including the Zephyr operating system. So here we will configure the samples LightDB LED. Basically, what we want to do is to add LEDs to ESP32 development kit, which are not there, but you can connect them using cables, because the GPIOs are available on pin header. So in order to configure those new LEDs that you will attach to your board, you want to enter the board's directory, which is for board specific configuration, and for overlays to the application and to device tree. So right now,
so the configuration versus an overlay, what are the differences there then? Like what would people go into one versus the other for?
So as I mentioned on the beginning, there are two kinds of overlays. So you can change the application configuration. So for example, you can enable IPv6 or IPv4 stack, whichever you need to use. You can enable Wi-Fi subsystem, which is required for ESP32, and this is what happens in the ESP32.conf.
I see. Okay, so it's even though you're calling it a configuration overlay, it's the .conf file is that overlay you're saying?
Yes, that is right.
I see. Great.
So it is an overlay to the application configuration. So you add more stuff that you need only for the specific board that you want to use.
Yeah, it's like a set of variables that are like you're showing here, like they're how you, whether or not you're enabling certain things, how you're setting things up, what are some of the things you put in there, and some of these things are also in other files as well, right? So you could put some of this in some of this stuff could also get inherited from the prj.conf as well, right? For like specific to the individual file for a sample.
Yeah. So in this LightDB LED sample, we use networking. So this is what is enabled in the project configuration already. We always use IPv4, and we disable IPv6 just to save some flash space. We do use some logging, some shell, and embed TLS for secure communication. So those are generic application-specific things that we want to enable for whatever board you want to use.
Yeah, great. And so that allows us. So that allows it to be kind of more specific to the particular sample you might be doing, to the you might want to tweak some memory stuff. Maybe you have a smaller program, you want to make it more compressed, that sort of thing. You need fewer resources, that sort of thing. Okay, cool.
Yeah, and you enable libraries. So for example, in the sample we use CBOR payload, so we enable CBOR library to use within the sample.
Great. Okay, cool. So now let's go to the device tree overlay. So specific for an ESP32, again, if I'm showing like this little board I built, I basically hooked it up to a bunch of pins on this thing, and I wanted to allow to basically trigger LEDs using that LightDB sample we have.
Yeah, so as I mentioned, we have already here the configuration overlay for ESP32, which enables the Wi-Fi subsystem, the HCPV4 and other stuff that are related only to this board. And normally within this sample, we don't provide any device tree overlay because it's not needed. The Wi-Fi subsystem, when it's enabled, it just uses the Wi-Fi that is in chip, and that's it. We don't need to configure anything. But today we want to configure LEDs to actually control them from within the sample. So for that, we create a file called ESP32.overlay. And this name means that this will be an overlay for device tree.
Yeah. So it actually finds that it looks, so like as it's compiling, it's like, oh, .overlay file, I know what this is. Because you're also, when you're compiling, you're saying -b ESP32, and then it says anything with ESP32 at the beginning, I'm going to look in those files and see what's there.
Yeah, that's right. So when you compile, you specify the board, the platform that you want to build for. This is a ESP32, and the Zephyr build system automatically searches for the boards directory, and inside the boards directory, it searches for configuration overlays and device tree overlays. And those are applied automatically by Zephyr. You just need to use the correct path and correct file name for those.
You know, one of the reasons I wanted to make these videos too is because one thing when I was coming to Zephyr, it was just so confusing where to look. Like all of these different places that things could be, because there's like the project file, and then there's also higher than that. Usually there's a boards file directory rather that has all of these configuration things, and then also there's at like the top level of Zephyr, there's also all the boards that are available, and it's just like there's so many different places to look, and I'd like to explore that more in future videos, but like this is a good starting place of where this kind of information is supposed to go.
Yeah, so it's all described in the documentation. So there are like several stages of what files are applied, so which overlays are applied to the configuration before you actually will get the firmware. So those are all about conventions. So you can have, like, if you use the name of the board add .overlay, it means that you will add overlay for the device tree. If you add .conf, it means that you will add overlay for the configuration, which is board specific. You have the prj.conf, which is in general a configuration of the application. And you can also have application.overlay, which configures the device tree, which applies the device tree overlay for all the boards that are used within the project. So yeah, it's good to go to the documentation page of Zephyr and follow them, but in most cases you have just the prj.conf, which is project configuration, and then you have the board overlays, which are the configuration overlay and also device tree overlay.
Great. Okay. So what is in the ESP32.overlay then?
Yeah, so this is the file that we just created. The contents of this file are in the Goliath documentation. So here we assume that we want to attach 4 LEDs to ESP32 development kit. And those are all connected to the pin header of the development kit. Here we configure in the device tree where each of the LED is connected to which GPIO port. So for example, here, the first LED is connected to GPIO port 0, pin 5. The second to port 0, pin 18, 32, and 19. And then
this is effectively like a lookup table for the real world, like where those LEDs are hooked.
Yeah, that's right. So as you mentioned, it's a lookup table, so you can name all those LEDs for all boards the same. So always LED 0, 1, 2, and 3. And here you provide the map, what it means for a specific board. And then in the application code, you can always call, let's say, turn the LED 0 on or turn it off, and it will work on all the boards, whether it will be ESP32, NRF, STM32, whichever board you want to use.
Yeah.
So
this is really the magic piece of doing like Zephyr, where you can switch on the command line and literally you could retarget a different board. It's not something that people do super often, but when you need it, it's just like, oh my gosh, this is so cool,
Yeah, it's very helpful for evaluation and also for testing with when you don't have the actual device. So you want to use some development kit. You might not have the one that is closest to the hardware that will be designed, but still it allows you to develop application that will work on many boards.
Yeah. Yeah. Yeah.
And the
I think
interface
about,
is always the same.
yeah, exactly. I think about comparing it to like doing past embedded development where it's like, oh, I'm going to write to this register and I could, I could or in a value, for triggering a certain bit inside a register, and that might then turn a GPIO high or low, and like that's nice to be able to have that direct connection. But then when I switch boards or I switch, like you said, switch between a development kit and my board, I might have to redo the whole thing because it might be a different pin, it might be whatever, and now it's just LED 0 or LED 3, and so that really does help to abstract a lot of the other stuff that's out there. And so there are a lot of steps to get to this point, but I feel like once you have it, then it's kind of done for a while. You don't have to do much after that.
Yeah, you have this flexibility, so you can always change the port where the LED is connected, and also change the MCU also.
Yeah, yeah. I mean, and in the days of not being able to buy chips as we are currently, it's more realistic that you might have to retarget than in the past. So it's a nice option to have.
That's right. Yeah, so here we have the configuration of the LEDs that we want to use. So all of those LEDs are GPIO LEDs. So here the compatible string specifies that all of those LEDs connect. When controlling those LEDs, you will always call the GPIO API. And here we just specify aliases. And aliases are things that just simplify the naming in your application. So you just want to always have the LED 0, 1, 2, and 3 on all the boards that you will use. And then in the application code, you can select the LED by using an alias. So you don't need to specify GPIO 0 pin 5, but just use LED 0, and that's it.
Yeah, yeah. So you could pretty much call it whatever you wanted here, right? You could call it Blinky 25 if you wanted to, or whatever it might be. But yeah, that really does allow you to have more flexibility. I think even on, I was actually looking at that on, I think on the NRF91 board that we often target for Goliath, and I think it had like 4 different aliases. It was like blue LED, LED 0. I think it was maybe Jared Wolf's alias that he had created. It was like a couple different ones, and you could switch it out. And so it's nice to make it to put in multiple names if you wanted there.
Yeah, it's all about convention. So within Zephyr, lots of development kits use the same convention of calling the LEDs starting from LED 0 up to how many LEDs you actually have. So if you have 4 LEDs, it's LED 0 to LED 3. And then you can have one application that works on all the development kits, which is great.
Yeah, yeah. I can imagine for a chip company, especially where they have to maintain lots of development kits, that's super critical. But I can imagine then translating that to someone who's got a couple different products that they're supporting out in the field. It makes a lot of sense there as well. You could start to standardize across a product line you might have, and that could really start to make things easier for maintaining firmware, for testing, for doing more abstracted testing, maybe moving out to a virtual device even, and doing that sort of thing. You do a lot of virtual device testing, I remember.
Yeah.
Great.
Yeah, and right now, if you want to use the LEDs, can actually look into the source code of the sample that we'll use and see how the LEDs are used. So here we see that we use some magic macros that allow us to get the specific GPIO number and GPIO port and GPIO pin number of LED that we configured. And here we have the listify function that will just list here, put all the LEDs that we have configured in device tree overlay. I will show the device tree here. And so all those LEDs, those 4 LEDs are put here in the in a C array. And what this sample read does, it iterates over all those LEDs and this initialized array and configure them on the beginning. This is just on the application starts in the main function.
Right. Yeah, so any application file could then go and basically look up what's in the device tree, what's available for me to go and use as a resource, and like you said, initialize and start using them later in the program.
Yeah, that's right. And later this application connects to Goliath, to the LightDB service that Goliath implements. And it gets the values that should be set to LEDs. So for example, we get the CBORD structure, which says LED 0 is true, LED 1 is false, and yes, some other configuration for other LEDs. And all those LED states are configured using the function Goliath LED set. And this is actually the GPIO API from Zephyr that is used.
Mm-hmm.
And here, once again, we use the C array that we have initialized from the device tree that we have configured. So by using the ID, which will be 0, 1, 2, or 3, we automatically get which port and which pin number we will set. And the value comes from the function that calls Goliath LED set, which is actually in the handler that processes the message from Goliath. So in the application, we register a handler to always notify about changes in the LightDB. And when application developer changes this in the cloud, changes the value from false to true or true to false, then this handler is automatically executed on the device, and then the LED set function is called with the proper value, which is true or false.
Yeah, and so people could see that in the other videos we have about LightDB and the demos, and especially using the console now, it's even easier. There's basically like a window that just shows you can just set up your LightDB values, switch between true and false, and like it just lights up. And I've even abstracted it out for like controlling, it's just a digital output at that point, controlling relays, controlling MOSFETs, things like that. It really gives you a lot of capabilities for a lot of IoT solutions that are just, hey, I just need to turn on a light, or I need to enable a gate, or I need to unlock something. And it all comes back to GPIO. So you've already got all that stuff now. Using Goliath, you've already got all that stuff because on multiple boards, because you've used the device tree overlay, and you're using the Goliath service, you're using the device tree overlay, and then you're just flipping bits. And it sounds trivial for most people, but there's just so many layers that Goliath kind of now collapses down to make it a lot easier.
Yeah.
Awesome. Well, Marcin, thank you for showing us this stuff. We were going to do some more videos, hopefully. We might show how to add other stuff to the device tree, other interesting things like sensors and interfaces, things like that. But for now, this has been a really good introduction to the device tree, and just kind of getting more comfortable with Zephyr. That's really what we're trying to enable here. There's a lot of people that are getting into it, and hopefully we're going to make it easier for them to try things out. So thanks for doing that today.